The theorem shown here will give the formula for the nth term of an arithmetic sequence as well as the formula for the sum of the first n terms of such a sequence. So if a sub n is an arithmetic sequence with the first term a sub 1 and the common difference d, then the nth term of that sequence is a sub 1 plus n minus 1 times d for any n that is greater or equal 1. And the sum of the first n terms of such sequence is a sub 1 plus a sub n over 2 times n, which means it is an arithmetic average of the first and last term in that sum times the number of terms we are adding. To justify the first part of that theorem, namely the formula that a sub n is a sub 1 plus n minus 1 times d, we'll simply use the definition of an arithmetic sequence. We know that for arithmetic sequence, we'll have that a sub n minus a sub n minus 1 is always d. So in particular, if you take the n equal 2, we'll have a sub 2 minus a sub 1 is equal d, which can be rewritten, and we can solve this equation for a sub 2, and we'll have a sub 1 plus d. Also, we know that if you take a sub 3 minus a sub 2 and equal 3, this difference is also d, and therefore a sub 3 is a sub 2 plus d. But a sub 2 was a sub 1 plus d. So if we use this in this formula, we'll have that a sub 3 is a sub 1, and we'll have 2 d's. And then if we take n equal 4, we have a sub 4 minus a sub 3 is d. And therefore a sub 4 is going to be a sub 3 plus d. But again, the a sub 3 term is a sub 1 plus 2d. So if we replace a sub 3 with that quantity, then we'll have that this is a sub 1 plus 3d. And if you look at this formula, you can notice that each of them, a sub 2, a sub 3, a sub 4, have a sub 1, and they have all a d. The only thing different in them is the coefficient of d. And if you look at this coefficient, it is always one less than the index of the term, and therefore we'll have the formula that is shown here. As for part 2, we'll use what we just discovered, that a sub n is a sub 1 plus n minus 1 times d, and therefore we'll write the sum a sub 1 plus a sub 2 plus a sub 3 plus a sub 4 plus and so on until we arrive at a sub n. We'll write each term using a sub 1 and d, so a sub 2 is a sub 1 plus d, a sub 3 is a sub 1 plus 2d, a sub 4 is a sub 1 plus 3d, and so on. We'll continue that until we'll arrive to the term a sub n, which is a sub 1 plus n minus 1 times d. Notice that we have a sub 1 appearing in that sum n times, every once per each term from 1 to n, and therefore if you add them all, we'll have n times a sub 1. And then we'll have terms with d. We have d, 2d, 3d, and so on until n minus 1d. From all that remaining terms, we can factor out d, and what will be left is 1 plus 2 plus 3 plus and so on until n minus 1. But what we have in the parentheses is the sum of the first n minus 1 terms of n minus 1 first integers, and therefore using the special sum we can write that this is d times n minus 1 times n over 2. We'll factor now from that sum n over 2, and we'll have 2a sub 1s plus d times n minus 1. And if we rewrite what we have in the parentheses again as a sub 1 plus a sub 1 plus n minus 1 times d, we'll see that the last two terms form a sub n. And therefore we'll obtain n over 2 times a sub 1 plus a sub n, which is really the right-hand side of that formula.